How's everybody doing? Great. My name is Matt Russell, president of the Colorado Springs Astronomical Society. Welcome. We haven't seen each other in 3 months. If you can believe it or not, our last general meeting here was in November with Fran Bagenal. So it's been a while. So wanted to briefly explain what we're going to be talking about tonight. First off, Stephen White is back. He's going to be talking about the having a solar system tour, right?
That's right.
Awesome.
Woo, yay!
So that's going to take us about 45, 50 minutes, somewhere there. We're going to then do observing reports. From what I understand, there was a fireball early February that maybe somebody wants to talk about. I know that there's some photos that I'd like to share, and then whoever else wants to give an observing report, that would be great. We're going to take a break. And then we're going to come back. Is Vince Villa here yet? There's Vince. Everybody look at Vince. He's very, very giddy tonight. He does our What's Up segment, and he likes Galaxy Secrets. So that's what he's talking about tonight, right? So, yes. And then what we're going to do is we're going to go into committee reports. We're going to talk about Star Scare. Just to give you a brief update real quick, numbers are looking really good on registration so far. We have some important updates from Very Young for our Starry Meadows land that we own. And then the other committee, I know Brian's going to be talking. Bruce might say a couple words. We'll do outreach reports. Dave's not here tonight, so I'm going to go over some of the highlights, and maybe you can help on some of those items, and then we'll adjourn. Normally at this time I say we have a hard stop at 8:30. I'm not saying that tonight. So I'll get into that a little bit later. So what I'd like to do is I'd like to announce our board of directors. Again, my name is Matt Russell. Doug Cook here is our vice president. Our interim treasurer is Scott Donnell.
And trustee.
Our secretary, Vicki Kitzman, right there. Tom Mulliken, right there, member at large. George White, is he here? No, he's not here. Stephen Plegio, our web director. And one thing I also want to do is I want to mention something about trustees. Don't get ahead of me. Floyd, can you stand up, please? Floyd has just completed a 2-year term as trustee, and I would like to thank you for your service. Everybody, thank you for your service. Our new trustee that has been board approved is Mr. Bruce Bookout right here.
You're saying I'm bored?
Board approved.
Oh, board approved. Okay.
All right, great. Well, this part of this meeting now is what I'd like to do is if there's anybody that's new here, that hasn't been here before, that's perhaps a new member that doesn't know anybody, I'm asking you if you would raise your hand and introduce yourself so that we can, engage with you at the break or whenever. So let's start right here. Go ahead.
Hi, David. Hi, David. Just I'd be interested in checking this out, see what it's all about. Kind of interested in astronomy.
Right, you have your own telescope?
No, that's part of why I wanted to come to see what some of the setups are. What's a good starting point?
Oh, perfect. You're at the right spot for that. What I would recommend is probably going to some of our Star Party events. We'll be going over that part at the end of the meeting, which there's just wait until you see the calendar. I mean, there's tons of stuff on it that you can really get an idea of what you want to do or what types of equipment are out there.
We're busy, you're one-legged man and butt kicking.
Who else? Yes, go ahead.
I'm John Phelan. I'm a philosopher. I'm retired from teaching. And I have a telescope that's about 40 years old, but I haven't used it the past 35 years.
So you have a young telescope compared to a lot of what we have.
So I'm interested again in astronomy, and I'll check you out and maybe get involved.
All right, awesome. Great. Yes.
Ed Minogue and my wife Robin here. We had gone to one of the dark sky viewing parties at Black Canyon at the Gunnison last summer. And after thinking about it, said, you know what, this is just too much fun. We wanted to get into doing our own observing. We just recently bought a new telescope, first one I've had since I had a little Pasco one 40 years ago. I want to get some more advice on what to see and where to go.
Perfect, perfect. Just to remind everybody, we have an attendance sheet at the back of the room. And
It's off the thing.
it's back there?
Yeah, it's back there,
Okay.
but there's no pen. So take a
Nope.
pen.
Take
What
a
happened to
pen.
my pen?
It's right here in my hand.
And then we also have little card, like registered visitor cards,
Also back there.
also back there. If you fill it out so we can get back in touch with you, or if you haven't joined yet or whatever, so, we can see how we did, that sort of thing. Anybody else? Yes.
I'm Amanda. I work with Steve, and that's why I'm here.
Oh, we're sorry.
Moral support?
Yes, yeah.
Awesome. Yes.
Well, I'm not a new member, but I haven't been involved with the club in probably 13 years, so.
Rebel?
I'm Jeff Venable, and I'm back. For those that don't know me, hello.
Good to see you again, Jeff. Good to see you. I thought I saw a hand in the back.
Yeah, I'm Kenneth Bradford, and it's our first year, so reported work. I have a couple of scopes. Got a little refractor and got the reflector. So,
Right on. Perfect. Thank you. Thank you all for coming. Anybody else? Perfect.
If I could make a quick one.
You want to make a quick
For
comment?
those of you who are new, assuming you do sign up, you'll want a name badge, or anybody who needs a name badge, catch me at the break, come put your name on here. And you have to be a member though to get a name badge.
Perfect. All right. Well, since it's been 3 months, I just wanted to say we had an awesome Christmas party. We had record attendance this year. There was almost 70 people there. It was a great time. So thanks everybody who brought food, brought meats, brought beer. It was a really good event. So
White elephant gifts were fun.
White Elephant gifts, yeah, that was a great time as
A
well.
lot of broken children's hearts.
That's right. We had a couple.
Wow, the kids were vicious.
They were. They always are.
Or the adults.
Right. Next up, I wanted to talk about is the jackets. We had a printing problem with the jackets. They have been returned to be redone. Basically, as you all are aware, at our probably October meeting, we decided to go with CS with a space and then Astro, as big as we could on the jacket back. Got it back, small font, no space. So that was their error. I give up on this. Who knows? We might get our jackets in July when we need them the most. So, but anyways, they're being redone. So just so you know that they are in the final stages of production.
Matt, is it too late to order one, or?
You'll want to contact Alan Gorski. I can probably give you his email address at the break.
Okay.
Or are you on the forums? Are you on our forums online?
Yeah.
There's a thread there that he responds to.
Okay.
That's probably the best way to do that. Next up, I normally don't promote this, but there's a movie opening this week if you haven't heard about it. Apollo 11. It is a documentary that is, from what I've read on the reviews, it's unbelievable. There's no commentary. It's all real footage of the Apollo mission in July of 1969. From what some of these reviewers are saying is that it's like they filmed it yesterday. So they've done some really cool footage restorations and whatnot of films that nobody's ever seen before.
It's only on IMAX the first week. So it's only at Cinemark at the IMAX starting Friday. And then the week after, then it's going to have a more broad show.
Right, and I was just checking the other day, or today actually, and the prices for like a matinee are like $11, $12, something there for an adult. So I want to check it out. Should be pretty interesting. Is Devin Delarose here?
Yes, sorry.
No, he's not. From what I understand, the planetarium at the U.S. Air Force Academy will be opening on March 4th.
Having a grand opening on Saturday.
Is that the 4th?
No.
Fourth is Sunday.
The second is, the second is, they're doing, you have to call to get tickets for it. But they're doing a 1-hour presentation with Steve Spangler and Arnold Hall. And then they're doing an open house from 3 to 4 at the planetarium, but you have to have tickets for that. And then
Okay.
March 4th, Monday, is the official.
Okay, perfect. Do we need more seats in the back?
Is there seats up here or seats over here?
5 seats up front.
Yes.
I think he has some books for you.
Oh, yeah, she's still a librarian too.
All right. As I mentioned, Scott Donnell, our past president, has been approved by the board for assuming the temporary treasurer position. Our bylaws do dictate, however, that in order to fill a vacancy permanently, we need to have a special election. So Vicki, if you mark in the notes that the president is calling for a special election next month to fill this position permanently. Scott has,
Well, not.
well, for the year. You know, for the year. I like him. So we need to get him into the position officially. If there's anybody else that wants to nominate another person for that position, speak to our other trustee, Bruce. Look out right here, because Scott, as a trustee, it would be kind of a conflict of interest if he handled the election next month. So there's the notice, and I will be sending out a presidential communication for the mail requirement of that. So just keep that in mind for next month. If you're not planning on being here and you do want to vote, send president@csastro.org a proxy, and I will make sure that it is counted in the vote total. I just need that 7 days prior to the election. So keep that in mind. Next up, lunar telescopes. Our club has, over the years, we've gotten a lot of donations. We've spent the last 2 or 3 months going through, actually probably longer than that now, going through all of our inventory, and we've decided that we are going to be getting rid of some stuff, and we're going to be keeping some stuff. So Fred Goodman, where are you? You want to say anything about what we've done?
Well, I want to thank the team, and they all know who they are that got together. That was one of them too. And what we did is we make it as quick as I can. Decided what was worth using by anybody, let alone us. Some things will just be going out the window. We now have forms that, as a club member only, you can borrow scopes. And we have 4 categories of different kinds of scopes available. So if you're interested as a club member, see me, I'll give you my email address, and then we can do this through email. And you get 60 days up front if you can borrow it with extension if possible.
Perfect. Thank you. So talk to Fred about that if you're interested in borrowing one of our telescopes. One thing I want to talk about now that I mentioned earlier was our hard cup for meeting times. For those of you that have been in the club for a number of years, you realize that we have an agreement with the Space Foundation here. Basically, what the agreement entails is we would provide 3 start parties a year for the Space Foundation, one of which was the Space Symposium, and then 2 other start parties throughout the year. In turn, they would give us this meeting space 10 times a year. Well, our agreement expired in January of this year. And in, I would say, late October, Travis got back with me and was wanting to improve our relationship. And what he came back to me was, or came back to the board was, that they would like to do 6 start parties a year. Okay. Seems like a lot. However, I don't know if any of you know this, we did 8 or 9 start parties with the Space Foundation last year. So it's not that much. So our goal was also, if the original agreement we thought was a very fair agreement. However, with this additional Star Party request, we wanted to change some wording around. For example, we didn't want to use the word Star Party. We wanted to use the word event so that we could do events with them during the day that would count as credit for that. The first Friday of every month, they do a homeschool day here. So perhaps some of those days. They do library events every once in a while. So we were able to change that wording around. Another thing that they wanted to do, which is not a big deal at all, because they give us the space, honestly, is they wanted twice a year to have a 2, 3, 4 minute segment twice a year to explain what volunteer opportunities are available at the Space Foundation if anybody wanted to volunteer. That seems fair to me. They also wanted to also work better with joint marketing of our events that we do together. I told them flat out they don't want to deal with Dave on everything because they need to hire like 3 or 4 more people to keep up with that guy. So we decided that it's probably best if we just jointly try to market events that we're doing together. Okay. In return for this, one thing that they agreed to do was they agreed to set up our meeting space in this meeting, what we call CS Astro meeting configuration, where we have the tables up front, chairs in the back, room for Stephen on the side there. That's one thing. Another thing that we asked for was board meeting space for 6 times a year, 2 hours each, have board meeting space available to us. We're still trying to work through that because they're having some scheduling issues with evenings. So what I told them is that we can be as flexible as possible. It doesn't need to be hard-coded every month. We'll make it work. The money shot here is we have agreed to extend our meeting times. So we have this room reserved now from 6 p.m. until 9 p.m. So that'll help. That'll help first off with meeting overruns, which happened several times this last year. It'll help with more social time, which I think is extremely important at these meetings. So either we have more social time at the beginning of the meeting, have a longer break in the middle, combination of both. We have some time at the end. So I think it's a win-win for everybody. So they have not yet given me a written document, but we've been in communication over the last couple of weeks, and it appears to work out well so that all parties benefit from it. So that's one of the things that we've been working on. One of the last things before we get into Stephen's presentation is this is the title of my little segment here. It's called "Make a Difference: Combating Light Pollution and Getting Involved in Your Community." Would Scott Daniel, Tom DeClue, and Fred Goodman please stand up? Last December, us 4 went to a meeting that we were made aware of in Latigo Trails. For those of you who don't know where that is, it's an equestrian center in Black Forest regarding a potential large development at the corner of Meridian and Hodgson Roads. Scott, his wife was there as well, and Fred are directly impacted by this development, where Tom and I are a little bit further south. We're not so impacted. So we went to this meeting, and our obvious concern was light pollution of this development. I can't remember how many homes are in this development.
240.
240 homes. It was very, very interesting. It was a very interesting meeting. For those of you who have known me for a long time have known that I've battled light pollution before, and I've been slandered in the paper as being an environmentalist, some kooky save the whales guy. Seriously, look it up. Especially when the streetlights issue was going on in the early 2000s. So we went in there, and we based on that experience that I had, the experience as a developer, one of the things that we decided to do was go in as individuals, not go in representing a group or something so that we could be tarnished or labeled as kooky, crazy environmentalists or whatever. So we went in as landowners. And believe it or not, what was very interesting in this meeting is, yes, a lot of residents were concerned about water and is my well going to run dry? But 40, 50, 60% of people were concerned about light pollution. And we made it very clear on our end that, you know, non-shielded lights were not cool. It would distract from the development. It would distract from our science stuff that we work on. It would distract from the STEM stuff that we've done out in our area, right?
Yeah.
Anything else you'd like to add before I read a part of an article in the paper?
I would just like to add that we did hear from the developer that they had already embraced the concept or the notion of dark skies and responsible nighttime lighting. So it was actually kind of refreshing to see the developer had already given thought to that before we even arrived.
Right, and I think it was great that us and other people really enforced that. I thought that was really cool. So just real quickly here, I just want to say, Smith & Proterra is renaming the project to Winsome. The vision for this property is to meet the demand for people who want a rural lifestyle by retaining open space, providing a trail system, implementing a dark skies initiative that limits the amount of outdoor lighting while maintaining community connectivity. So I think we did make an impact. So thank you guys for doing that. I appreciate it. Okay. How about you? Good. It's a water. All right, Stephen, are you ready? All right, well, I would like to hand over the floor to Stephen. We're going to have a presentation. Do you want me to come in? Yes, please.
He does his best work.
Yeah.
Make sure it works. All right, so before I start, I actually like to give a shout out to my son Kyler. It's his first birthday today, so. No, it was supposed to be 1 year, but it was in March, and it was 1 month after she got out of the hospital. So, you know, I'll keep this track record of every time it's his birthday, I'm going to do a presentation. So, happy birthday, Kyler. Now, when we do star parties, a lot of cool things are outside of our solar system. M13, the Orion Nebula, the Andromeda Galaxy, the Leo Triplet, all these things are amazing to look at. Sometimes we're so amazed about things outside of our solar system, we forget how amazing our solar system actually is. Join me tonight as we take a trip through our amazing solar system. Now, our first stop on our cosmological journey, our solar quest, is where we get our name solar system from our star, Sol. Now, contrary to popular belief, our sun is not yellow, despite being classified as a yellow dwarf. It is, in fact, white. Now, the reason it looks yellow-orange is because of our atmosphere. Outside of our atmosphere, our sun is undeniably white. Now, our sun is by far the most massive object in our solar system. It's not even close. The sun itself accounts for 99.8% of the entire mass in our solar system. It is 1.3 million Earths can fit inside of it. It is over 430,000 miles across. Now, some people say that our sun is a middle-sized average star. That's kind of misleading. Sure, the sun is only 50% of the relative sizes of all the stars in our galaxy, but is in fact bigger than 90% of every star in our galaxy, most of the stars being tiny red dwarfs. Speaking of our galaxy, our sun is 26,000 light years away from the black hole at the center of our galaxy. That means light that is emitted today won't reach the black hole at the center of our galaxy for another 26,000 years. Our sun is 2 octillion tons. That's 2 followed by 27 zeros. It is made up of hydrogen and helium with a smattering of other elements. All this mass produces something amazing in the core, fusion. Every second of every day, 700 million tons of hydrogen is fused into 695 million tons of helium. The other 5 million tons is released in the form of energy, thanks to E equals mc squared. That is equivalent to 15 Empire State Buildings getting formed into energy every single second. Now, all this fusion puts off a lot of energy. Our sun's surface is almost 10,000 degrees Fahrenheit, with its core almost 27 million degrees Fahrenheit. Now we look at the size of the sun compared to some of our objects in the sky. First, we have the sun compared to our planets in our solar system. If you notice, there's little asterisks. And down here you can't read, but it says not a planet. I will get to that. Where Pluto is not a planet. Controversy, I know. Okay? You got to read the fine print. So, in this picture, we see the size of our own star compared to other stars. First, we look at the red dwarf, Wolf 359. This is the star system where the Federation suffered a spectacular defeat at the hands of the Borg, led by Locutus. For all my Star Trek fans out there. Okay, good. I got a few laughs. All right. So next, we look at the sun compared to the brightest star in our sky, Sirius. Then we notice how small Sirius is compared to the stars Arcturus and Aldebaran. And then we see how small Aldebaran is to Antares and Betelgeuse. And then we see how small Betelgeuse is to these hypergiants. So for perspective, we have VY Canis Majoris, one of the largest stars in our galaxy. And we see this little itty bitty guy right there. Okay, that's our sun. And then the orbit of Earth compared to the star VY Canis Majoris. So there are really big stars out there, but our sun's pretty cool. Now we're going to visit the planets in our solar system. Now before we talk about planets, I think we need to define what a planet actually is. Prior to 2006, there was no hard and fast definition of what a planet was. In 2006, the International Astronomical Union defined what a planet is. Does anyone, besides Bruce, want to guess what would define a planet? Yes. Okay, so it has to orbit its parent star, so orbit the sun. Another one? It has to be spherical in nature due to gravity. And a third one?
It has to be large and go with relative object.
And it must have, I'll take it. It must have enough gravity to where it's cleared everything else of relative size to it from its orbit. So it must orbit a star, must be spherical in nature due to gravity, and it must be big enough that its gravity has cleared out other objects of similar size. Now, what about Pluto? Is Pluto a planet? Well, let's go down our checklist. Okay. Does it orbit a star? Yes. It orbits the sun. Is it spherical in nature due to gravity? Yes. Yes, it is. Has it gravitationally cleared everything else out of its orbit? No, it has not. It's not even the largest thing in its orbit, which we'll get to later. So, Pluto is not a planet. It is, in fact, a dwarf planet. Dwarf planet is defined as something that orbits a star and is spherical or nearly spherical in shape due to gravity. Dwarf planets are not planets, just like dwarves, hobbits, and elves aren't people.
You Tolkienite.
Oh, yeah. I went there. All right, our second stop on our journey is the first of the planets, Mercury, named after the swiftest of the Roman gods. Now, Mercury is the smallest planet in our solar system. It has a radius of 1,516 miles, slightly larger than our moon, and is about a third the size of Earth. It has an average distance of 36 million miles away from the sun, and on average, the sunlight reaches it in about a little over 3 minutes, and it has no moons. Next slide. There we go. All right, now, in 1639, it was observed that Mercury undergoes a complete cycle of phases like our own moon. This is not possible in a geocentric model where the Earth is the center of the solar system. This is only possible in a heliocentric model where the sun is the center of the solar system. Now, back at that time, they thought the Earth was in the center of the solar system and everything revolved around us, but no, that's not true. Okay? It is covered in craters and is extremely dense. It's the second densest planet in the solar system, with our Earth being number one. We're number one. Woo! All right, I'll take it.
Earthlings are dense.
Yes. We'll actually get there. It has a rocky surface and a large core. Now, because Mercury is so close to the sun, it was thought that it would be tidally locked in a 1-to-1 ratio with the sun, where its day is equal to its year. But that's not what we observe. When we observe it, we notice that one day is 59 Earth days long, with its year being 88 days. This is almost a 2 to 3 ratio, which is a stable ratio for these orbits. Now, temperature on its day side is 800 degrees Fahrenheit, with its night side being negative 290 degrees. This is the largest temperature swing of any body in our solar system. Now, fun fact, there are deep craters on its poles that are in perpetual darkness and never see sunlight that actually has icy water on it. Yes, there is icy water on Mercury, which, despite being the closest planet to the sun, Mercury is not the hottest. That honor goes to Venus, named after the Roman goddess of love and beauty. Now, Venus is known as Earth's twin, being 95% its radius and 80% its mass. But if it's our twin, it's an evil twin. Temperatures on Venus is over 900 degrees Fahrenheit. That's hot enough to melt lead. It has an average distance of 67 million miles away from the sun. Takes like about 6 minutes to reach Venus. Venus has no moons. Like the moon and Mercury, it also goes through in a complete cycle of phases. There's a check mark in heliocentrism. Now, calendars on Venus would be completely useless. One day on Venus is longer than its year. One day is 243 Earth days, and 1 year is 225 Earth days. Another weird thing about the planet, it spins backwards on its axis with respect to Earth. It is the third brightest object in the sky. Now, some people, not us because we're astronomically literate, okay, but some people have seen Venus being so bright in the night sky, they have been known to dial 911 and report a UFO when it's really just planet Venus. Now, Venus's orbit is tilted 3 degrees with respect to Earth. That is why there is not more Venusian transits, where Venus would go in between us and the sun. These transits occur 8 years apart and then do not happen for over another 100 years. Our last transits were in 2004 and 2012. The next transit won't happen until December 10th, 2117. I don't think any of us is going to be alive for that. Now, Venus's air is almost completely carbon dioxide. Its atmospheric pressure is 90 times that of Earth. So not only would you die of heat stroke, but you'll also be crushed under the pressure of the atmosphere. And it also rains sulfuric acid. But, silver lining, it is so hot, the sulfuric acid evaporates before it hits the ground. So even though you died of heat stroke and, crushed, you won't have sulfuric acid raining down on you. So silver lining on that one. Okay? This atmosphere is due to a runaway greenhouse effect. The sun warmed up Venus enough to where the ocean started to evaporate. This released carbon dioxide that was in the oceans, thus making it even hotter. And this continued to get hotter and hotter to where carbon dioxide was even baked out of the rocks on Venus. There are hurricane force winds on Venus, where on average, Venus's winds are 224 miles an hour. Put that in perspective, Hurricane Patricia, which has the strongest hurricane winds on Earth, was only 214 miles an hour. Despite all these conditions, the Soviet Union's Venera 13 spacecraft lasted more than 2 hours on its surface before it suffered catastrophic failure. Now, for a fun fact, Venus is so weird, it actually snows metal. So, sulfuric acid and metal. Awesome. All right. So, our next stop on our journey is our fourth stop is the third planet, Earth. Now, unlike all the other planets, our planet is not named after a cool god or goddess. It's named after an old English word for dirt. So, extremely boring. I know, I want something cool. So because we live here and we know the most about it, I'm not going to spend too much time on Earth. It's the largest of the terrestrial planets, the first 4. It is 3,959 miles in radius. It has an average distance of 93 million miles away from the sun. It takes light about 8.3 minutes to reach Earth from the sun. One full rotation is 23.9 hours, and 1 year is 365.25 days long. It's tilted on its axis by 23.5 degrees, and it's the only planet with large amounts of liquid water on its surface. We are the only planet with exactly 1 moon, and our moon is about the quarter of the size of us, making it the closest ratio of planet to moon in the entire solar system. Now I'm going to break from my tradition of fun facts and give a pretty sad fact. So in a recent survey, a third of young millennials are confused. They think that the Earth is flat or don't know that the Earth is a sphere. Although technically it's an oblate spheroid, but I digress. Okay? Now, this is, I don't usually say this, but this is going to be the one and only time I say this. I'm going to go back for the millennials. Technically speaking, 18 to 24-year-olds are not millennials. Those are Gen Z. Okay? Millennials are only slightly more educated, at only 24% thinking that the world's flat. 10 million Americans between the ages of 18 to 24 think that the Earth is flat. This is extremely disturbing to me. In the age where we have the entire human knowledge in our pockets, people are still holding by ideas that are over 2,000 years old rather than understanding the facts that are today. So rounding out this survey, 18% of 35 to 44-year-olds refuse to accept reality, 15% of 45-year-olds to 54-year-olds live in fantasy land, and holding strong in only 6% of 55 years and older are people that are senile. So the older generation is showing the young guns what's up.
How many 55 plus are in here right now? Yeah, okay. Let's give them senile.
Look in the mirror.
How many of those millennials are unemployed?
All of them. Yes. All right. So our next stop is we reached the first satellite of a planet, our closest cosmological neighbor, Luna, the moon. Now, when people think of the moon, they may think of this first picture, a large spherical rock right next to our world. But it doesn't look like this. In fact, it looks like this. It is it's almost 239,000 miles away. More than 30 Earths can fit in between this distance. It takes light about 1.25 seconds to go from Earth to the moon. And if you were to drive a car at 60 miles an hour from Earth to the moon, if you can, build a road, it would take 160 days to go from Earth to the moon. Not a problem, yeah. Like road trip. So whenever the Apollo astronauts were on the moon, it took about 2.5 seconds for the transmission to go from Earth to the moon and then back. So whenever we ask a question, we have to wait 2.5 seconds before we got the response. Now, it is the 5th largest moon in the solar system with a radius of a little bit over 1,000 miles. The other moons that are bigger than it, we have Ganymede, Titan, Callisto, and Io. And the moon is about the size of a small pill held at arm's length. It is tidally locked with the Earth, which is the reason we only see one side of the moon. Despite this distance, 12 Americans have walked on the moon. Something I like to say, there are 2 types of countries in the world, those that use the metric system and those that have walked on the moon.
You're going to pay for that.
Now, the surface of the moon is made up of 2 topologies. The highlands, the bright, heavily cratered areas, and Maria, darker, smoother areas. When the Apollo astronauts came back, we were able to radiometrically date these rocks. Craters in the highlands were dated to be over 4 billion years old, while the Maria surface was younger, about 3 to 3.5 billion years. Another thing that's cool, on the poles that are in perpetual darkness, there is water ice on the moon. There could be up to 1 billion tons of water ice on the moon. This could help with a lunar base because water is heavy to transport, so we could have water already staged on the moon for a permanent lunar base. Now, in 1959, the Soviet Union took the first photo of the far side of the moon. And this was the picture. And then, of course, Americans being better, we got a HD TV photo right there compared to the communist.
That's 50 years late.
No, this was Apollo 16. Yeah. That's what Google said. Google's always right. So the far side is actually completely different than the near side. It's heavily cratered with very few Maria. And the crust of the moon on the far side are many miles thicker than the near side. this was a mystery until the astronauts brought back materials and we actually studied them. So through the ages, there are many mythological ideas of how the moon formed. Last century, there were three leading hypotheses. First, the hypothesis that the moon formed somewhere else in the solar system and it was trapped by Earth's gravity. Yet another hypothesis where the Earth spun so fast when it was forming that a piece of it split off and became the moon. And then a relative latecomer, the giant impact hypothesis. This hypothesis stated that after about 50 million years after the Earth formed, a Mars-sized asteroid, unofficially named Theia, slammed into Earth at a glancing blow. This would have caused lots of matter from the crust to be ejected from the Earth and coalesce into our moon. Now, is there any evidence for any of these hypotheses? Let's take a look. For the first evidence, or the first hypothesis, where the moon would form somewhere else and was captured in Earth's gravity, that means that the material on the moon would be completely different than Earth because it formed elsewhere. This isn't what we found. We found that the material on the Earth was similar to Earth. So that falsified that hypothesis. Second hypothesis, where the Earth spins so fast that a piece of it just flew off into space and formed the moon, that means that the material would be exactly the same as Earth because it formed only from the Earth. But again, that's not what we find. While the material is similar to Earth's, there are different isotopes of elements that were returned from the moon, falsifying that hypothesis. So if the third hypothesis is true, we would expect to find that while there is different isotopes on the moon, it would be similar, but not exactly the same as Earth. And also it would be heavy in material that was from the crust of the Earth and very little in the mantle core, because a glancing blow would not have ejected materials that were from the mantle and core. And this is exactly what we found. If an asteroid hit Earth that was that large, it would turn Earth into a molten ball and would become a blast furnace to the moon. So as the moon coalesced, it would have melted the near side and the rocks would have evaporated and condensed on the far side. And that is the reason why it is thicker on the far side than the near side. So next, our step is the last of the terrestrial planets, Mars, named after the Roman god of war. Mars has an average distance of 142 million miles from the sun. It never gets closer than 37 million miles away from Earth. Its day is almost the same as Earth, about 24 and a half hours for its day, and 687 days equals 1 Martian year. It takes light from the sun a little bit over 12 minutes to go from the sun to Mars. It's about half the size of Earth with a radius of 2,105 miles. It has an average temperature of 81 degrees Fahrenheit. But at noon, on some days that the weather is good, it could get up to 68 degrees Fahrenheit. So it could be warmer than it is here. It is not red because of blood, as the ancients thought. It is red because the ground is rusty. It has the largest volcano in the solar system, in Olympus Mons. Mars has 2 moons, Phobos and Deimos. These look more like asteroids than what we would think of moons, and will probably capture from the asteroid belt. Phobos is getting closer to Mars and will eventually, in a few million years, actually crash into Mars, and then Mars will only have 1 moon. So the Soviet Union was actually really good at landing on Venus. Well, NASA was really good at landing on Mars. They had many successful landings on Mars, but there was one that was not successful, the Mars Climate Orbiter. Now, for this one, you had 2 different, I would say, types of people working on it. You had the ground station crew that whenever it was doing all its calculations, it's going to use the imperial system, the Reich system. And then you had people working on the actual probe itself, and they were using the metric system. So as the Mars Climate Orbiter was heading towards Mars, the two, the ground station and the orbiter, kept on getting different readings, because one was in Newton pounds and the other one was in foot pounds. So they kept on giving different readings, and NASA decided we're going to go with the ground station because we're here in, America. Yeah, metric. No. So 5 times adjustments were made. And then whenever we put, okay, probe go into orbit, well, it was kind of off track and then it slammed right into Mars. Now, I'm not saying which unit was right, but remember, there are 2 types of countries in the world. Just saying. So there used to be a lot of liquid water on Mars billions of years ago. We have evidence of dried riverbeds, dried lakes, carved canyons, sedimentary layers, and minerals that we know need water to form. Curiosity rover also found organic minerals on Mars and recently found organic minerals that could have been used for food, for organic life. It used to have water, used to have atmosphere, and had a source of food. Could Mars have supported life? I hope one day we find out. Now, for our fun fact, SpaceX has planned a manned mission to Mars in the 2020s, and NASA plans a mission there in the 2030s. And now for a bonus fact. February 13th, 2019, the Opportunity Mars rover was declared dead after it was unable to wake up from hibernation due to a dust storm that came by. This mission was only supposed to last 90 days, but it lasted over 15 years.
Almost 14.
Sorry.
Under 15 years.
Under 15.
Almost
under,
to 15.
Almost to 15. I like to round up. Okay. Its final transmission, and like this pulls at my heartstring, this was its final transmission to humanity. My battery is low and it is getting dark.
That's a
That's a
urban
translation.
legend that has been already snoped down to death.
Really? It's on Google. It has to be true.
Are you joining those millennials and changing your mind?
Hey.
No, he's going with the old type.
Yeah, I'm going to see that. I still like it's a good story, but I guess it's not true. All right. So our first planet in the outer solar system is Jupiter, named after the Roman king of the gods. Jupiter is huge. It's over 43,000 miles in radius. Over 1,000 Earths can fit inside of it. It is twice as massive as all the other planets combined. It's 11 Earths wide and 300 times as massive as Earth. And it's 2 septillion tons. As of today, there are 79 confirmed moons that are orbiting Jupiter. And I actually got to see one of a solar eclipse on Jupiter from one of these moons. It happened during a star party while I was looking at it, and it was kind of funny because at first I didn't know what I was looking at. I saw a spot, and I thought, well, I thought it was the red spot, the giant red spot. But I thought to myself, that can't be the giant red spot. It's in the wrong hemisphere. And then I actually gasped in amazement and jumped up and down as I saw it move extremely fast and off of Jupiter, and I realized it was the eclipse. Yes, I am that nerdy. I did actually jump up and down, woot, and all that cool stuff.
Just use his first triple.
Jupiter, despite being so large, rotates extremely fast. One day on Jupiter is 10 Earth hours, and it's about one Jovian year is about 12 Earth years. Even at 500 million miles away from the sun, it is so large and reflects so much light that it is one of the brightest objects in the sky. Light from the sun takes about 44.5 minutes to reach Jupiter. Fun fact, Galileo viewed Jupiter through a telescope and saw 3 lights around it. A few days later, he saw a 4th. He correctly deduced that these were actually moons that were orbiting another planet. The first time he was seeing other moons orbiting another planet, actually the first time he saw anything else orbiting something else besides the Earth, which if there's other stuff that is orbiting around another planet, not everything can orbit Earth. Jupiter does have rings. However, it wasn't discovered until we actually sent a probe there because they were so faint. And Jupiter is famous for its giant red spot. This hurricane is over right now it's 1.5 Earths wide, but back in the day it was 2 Earths wide. No? Bigger? 3?
2.5.
2.5. I got the half part right. It is a hurricane that is over 300 miles per hour. It was first seen in the 1600s. It could be much older. 1600s is just when we first spotted it. But the red spot is shrinking and could one day disappear, which will be a sad day because Jupiter is actually my favorite planet. So Jupiter's atmosphere is mostly hydrogen and helium. again with a smattering of other elements. Several hundred miles beneath the top of the atmosphere, the clouds transition to a liquid. And then below that, it actually turns into a liquid metallic form of hydrogen. It acts more like a metal than it does a liquid. At this depth, it is over 18,000 degrees Fahrenheit. That is hotter than the surface of the sun. Now, is Jupiter a failed star? Now, I heard some people talk about Jupiter as a failed star. Well, the smallest star that we know to ignite fusion in its core is 1/12 the size of our sun. Jupiter is 1/1000th the size of our sun. In order for Jupiter to ignite hydrogen fusion, you would need to take Jupiter and add another 80 Jupiters on top of it. So no, don't think of Jupiter as a failed star. Think of it as a really successful planet. So is Jupiter Earth's guardian angel? Jupiter's gravity has been known to affect orbits of comets and fling them away from the inner solar system, saving Earth from possible impacts. But its immense gravity has been known to actually throw comets at Earth, so is it really our protector? I call it a love-hate relationship. So sticking in the Jovian system, we are going to talk about 4 of Jupiter's moons, the Galilean moons. In 1610, Galileo observed 4 moons orbiting around Jupiter over a week of observations. If Jupiter wasn't so massive and drowning out these moons in its light that it reflects from the sun, they would be naked eye objects. One mnemonic that I use to remember the Galilean moons in order from closest to furthest is I eat green carrots. This stands for Io, Europa, Ganymede, and Callisto. Io is the first moon, slightly bigger than our moon and 4th largest in the solar system. It orbits Jupiter extremely tightly, where it takes about 1.5 days for it to complete an entire orbit around Jupiter. It is the most volcanic object in our solar system with over 400 active volcanoes. Europa, this one is actually my favorite moon, is the smallest of the Galilean moons. It has more water underneath its surface than all of the water on Earth. This water has been seen to be rich in salt and organic material having carbon-based compounds in it. Could there be life on Europa? I really hope so. NASA is going to be wanting to find out, and they're going to be sending a probe in 2023, and Congress has mandated that there is actually a lander on this orbiter to actually land and go into the subsurface of Europa. Ganymede is the next moon in the Jovian system. It is the largest moon in the solar system. It also has large oceans underneath its surface. Finally, we have Callisto, the 2nd largest moon of Jupiter and the 3rd largest moon in the solar system. This orbits Jupiter about over 1 million miles away. The 6th planet on our journey is the most beautiful of the planets, Saturn, named after the Roman god of plenty and wealth. Saturn is almost 900 million miles away from the sun. It also rotates extremely fast on its axis, where its day is a little bit over 10.5 hours long. Its year is 29 Earth years. It has a radius of over 36,000 miles, 9 times wider than Earth. It has 53 confirmed moons. Now, Saturn is most known for its rings. These rings are 175,000 miles wide. If you would take Saturn and its rings and place it in between Earth and our moon, it would reach 2/3 the distance between Earth and our moon. Now, something really cool. While there are part of the rings that are 1 kilometer in size, some of the rings average out to 10 meters. No, I did not misspeak. That's 10 meters. That's yards for us moonwalkers. So other parts, okay, good. I got a few laughs. That's good. All right. Now, these rings are not just solid rings that go around. They're actually made up of trillions and trillions of small icy particles. And they actually have gaps in between the rings. The biggest ring that you can actually see from Earth through a moderate-sized telescope is known as the Cassini division. This division is 2,920 miles wide, which is almost as large as the continental United States. from Los Angeles, California to New York is 2,782 miles. Now, it is possible that Jupiter is our protector from comets and asteroids, but we really do owe our existence to Saturn. Studies and models have shown that as the solar system formed, Jupiter started to move closer into the inner planets, but Saturn was able to put its brakes on it and pull Jupiter out. And we know this could happen because we're able to see other star systems where they have planets that are Jupiter's size inside of where the orbit of Mercury is. And we know that stars or planets that big cannot form that close to their stars. So even though Jupiter might be our protector, every living organism on Earth owes our existence to Saturn. If it wasn't for Saturn, our planet wouldn't be here, and I wouldn't be standing before you tonight giving this presentation. So Saturn, I tip my hat to you. So now, fun fact. Even though Saturn is less dense than water, technically speaking, if you got a bathtub large enough, Saturn would not float. This is because that bathtub that's so large would have such a big gravitational well that it would actually pull Saturn inside of the tub. So even though Saturn is less dense than water, it would not float in water. So our next planet on our trip is the planet that's the butt of all jokes. Uranus, the sideways planet, named after the Greek god Uranus. Uranus is 1.8 billion miles away from the sun. It takes light 165 light minutes to reach the sun and has a radius of over 15,000 miles. One day on Uranus is a little bit over 17 hours, and 1 year is 84 Earth years. And it has 27 moons. Now, Uranus is probably the most famous for being the sideways planet. It's tilted at 98 degrees. Now, this was the first planet that was discovered. In 1781, William Herschel saw Uranus, logged it, and then a few days later noticed that it moved relative to the background stars. He correctly deduced that this was a planet. Uranus has been seen before and logged, but no one understood that it was actually a planet. Now, he decided in great brown-nosing fashion he was going to name this planet Georgium Cetus, or Georgia Star, after the reigning king George III. Luckily, the name did not stick, and we got Uranus. Now, Uranus is 14.5 times massive as Earth. And because the atmosphere on Uranus is methane, some weird things happen. Pressure of Uranus squeezes the methane molecules and actually squeezing carbon out of the atmosphere to form diamonds. Yes, it rains diamonds on Uranus. There are oceans of liquid diamonds underneath the atmosphere. They say diamonds is a girl's best friend, so baby, I'm bringing home a planet-sized rock for you. My wife said if I actually did that to her before we got married, she would never have dated me. So,
especially where they're coming from.
All right, so Voyager 2 is the only probe to have visited Uranus. It did it fly by in 1986. This mission was launched in 1977. So even though it took 9 years to get to Uranus, that probe only had 6 hours to collect on the planet, rings, and its moons. Now, fun fact, even though Uranus is not the farthest planet from the sun, and Neptune does have, on average, colder temperatures, the planet that has the record for the coldest planet in the solar system is Uranus, with spots on it during its dark side on its winter, or during winter, is negative 300 degrees Fahrenheit. Now we reach the last of the real planets, Neptune, named after the Roman god of the sea. So 65 years after Uranus was discovered, astronomers noticed something weird with Uranus. It wasn't in its right location where the math said it should. So people used, or astronomers used orbital mechanics and theorized that there is an eighth planet out there. Once the math was done, an astronomer, Joanne Gall, actually went outside and discovered the planet that night. And it was only 1 degree away from where it was predicted to be. Johann. I'm speaking American. So Neptune was the first planet to be discovered using math. It is 2.8 billion miles away from the sun and 249 light minutes away. Its day is 16 hours, and its year is 165 Earth years. In 2011 was the first time it completed one orbit since its discovery in 1846. It has 13 moons and 1 awaiting confirmation. It is 17 times as massive as Earth, just over 15,000 miles in radius. Slightly smaller than Uranus, but a lot denser. Temperature here is a balmy negative 360 degrees Fahrenheit. Now, its wind speeds, if you thought Venus and Jupiter was bad, Neptune's wind speeds are upwards to 1,250 miles an hour. Now, as astronomers noticed, they looked at Neptune, they noticed something weird. It wasn't in its right location where they thought the math showed it should. So this led to the search for a 9th planet. Lo and behold, they discovered Pluto. But something didn't sit right. Pluto was far too small to affect Neptune the way the math showed it should. This was a mystery until it was visited by Voyager 2. When Voyager 2 did measurements on both Neptune and Uranus, it found that we've been using the wrong mass for them. Whenever the correct mass was used in its formulas, the planets were right where they were supposed to be, which means Pluto was found by accident. Now, one of the storms on Neptune is the Great Dark Spot. This is like Jupiter's red spot, but as the name implies, it's dark, and it's only about the size of Earth. Now, fun fact, Neptune was actually spotted before Uranus. Galileo actually saw it and logged it, and noticed it moved relative to the background stars, but he didn't correctly deduce that it was a planet. If he did, Neptune would have been discovered before Uranus, and our 8th planet would have been known before our 7th planet. Now I want to briefly touch on the dwarf planets. In the asteroid belt, we have Sirius. Out past Neptune, we have Pluto, Aries, Makemake, Haumea, and more than 200 other dwarf planets in the Kuiper belt. Pluto isn't even the largest of the dwarf planets. That honor is to Aries. If people think that Pluto is a planet and wants it taught in the school system, they must demand that every school child memorize Ceres, Aries, Makemake, Haumea, and all of those 200 other dwarf planets that are in the Kuiper belt. I don't think they're going to want to do that. So I'd like to leave you with this picture. When Voyager 1 was leaving our solar system, it turned around and took this picture of Earth, right here. It may not look like much, but this picture is extremely powerful. And I don't think anyone could sum it up as well as the great Carl Sagan when he says, if you look at it, you see a dot. That's here. That's home. That's us. On it, everyone you ever heard of. Every human being who ever lived out their lives. The aggregate of all our joys and sufferings. Thousands of confident religions, ideologies, and economic doctrine. Every hunter and every forager. Every hero and coward. Every creator and destroyer of civilizations. Every king and every peasant. Every young couple in love. Every hopeful child. Every mother and every father. Every inventor and explorer. Every teacher of morals. Every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. Science rules.
Does anybody have any questions for Stephen?
Why is Venus hotter than Mercury?
So not only is it, so Mercury is closer, yes. However, it's the atmosphere. Mercury doesn't have a big enough atmosphere to hold on to that heat. So as day side does cook, it lets all of that other, on the night side, it just lets off all that heat. On Venus, you have the atmosphere and all that carbon dioxide trapping in the heat, and it's just a cycle that continues to heat up the area.
So I noticed that as you went out, it was longer, and that makes sense. Really away from the sun, but I also noticed that the days are getting shorter. Is there any reason why that happens? Other than getting shorter,
So the days doesn't get shorter. It's, if you notice, Jupiter had the quickest day, and then followed by Saturn, and I think it was Uranus and Neptune. I think, don't quote me there, but I think it has to do something with the mass. Bruce, got anything on that?
Has to do a lot with how the planets all formed. When you're a big object, you think you would spin slower, and when you get smaller, you spin faster. But because of the densities and the original formation, it flip-flops back around. So it's an interesting, good question, observation there.
Is the moon hollow?
The moon is not hollow.
There
No,
was
it's
something
flat.
that they did some kind of test and it rang like a bell for a long time.
Technically, the Earth rings like a bell every time we have an earthquake.
Why do the planets spin? Why does one of them spin back?
So why one of them spins backwards? While we don't know exactly why, some of the one of the hypotheses is that it got hit early in its formation, and that collision actually spun it around on its axis. So that's why it spins backwards. So originally it was spinning correctly with respect to Earth, but after that collision, it flipped upside down.
But why do they spin in the first place?
So whenever they formed conservation of angular momentum, as the dust came in and spun, that is why it continued to spin.
Since we know that our poles have changed in the past and will change again in the future, will that have the same effect on us?
No, it wouldn't slow us down. It just have effects on your compass, your GPS. So I use GPS just to go to Walmart, which is a third of a mile away. So I'm going to be lost trying to get there once the poles switch.
GPS is not based off of magnetism.
That's why I use
Jupiter is gaseous, right?
Yes.
And you talked about landing on one of its moons.
Yes, the moons are rocky, but the planet is gas.
Can you say, does the sun rotate on an axis?
Yes, it does. And its equator actually rotates at a different speed than the poles.
Differential rotation to plasma.
And then it depends on, so whenever you, the way we know that is we see sunspots on it, cooler areas on the sun, and we see them actually orbiting or rotating on the sun at a different speed depending on what latitude they are on the sun.
Explain why the magnetic poles move around.
It has something to do with the iron core and the molten core that's in the Earth and the molten mantle. As it spins inside of Earth, it causes a magnetic field that just flip-flops periodically. It's not the same periodically throughout Earth's history, but it does change north to south, south to north.
Anything else? All right. Well, thank you very much, Stephen. Again, for those of you who are not aware of, this is, I think, your second or third. This is the highly prized Colorado Springs Astronomical Society and RMSS mug. We only give these to presenters. So thank you again, and there's your extra mug. Thank you very much.
There's one on eBay from username
All right, before we take our break, let's go ahead and go into observing reports. Is there anybody here that would like to have an observing report? Or that has one? Bob? Or Ron, sorry.
Wood, we're at the observatory for the school. We looked at the eclipse. And then the night before, I was out there at my home, away from home. Used my camera on my phone. Took some pictures of the night before the eclipse, and they came out pretty good. And Floyd and I did the same thing, and he had a big telescope, and then I was out there with the 6-inch on the 6 inch. And I was looking at that while he was setting up a big telescope. And he had binoculars, and he used that too. So,
Great. Great. You know, I know a lot of people been having a lot of success with using their cell phones and those little adapters. I think, Jim, you had some pretty fantastic images, didn't you, a couple months ago?
It's amazing what it can do, just holding it steady.
Right.
Bob Vixie made something to.
That's right. Bob, you made Bob has a wonderful platform for
it's a platform that attaches to an actually, so it's gonna remember, so that you can set that on
The lunar eclipse was a lot of very happy amateur astrophotographers.
Yeah, at the lunar eclipse at Bear of the Gods, I had quite a line, and the Gazette photographer, what's her name? Jerry Lee Bennett, came by and took a bunch of pictures and gave us a nice little write-up in the paper.
Oh, nice.
So if somebody wants to see this, I've got a few copies.
Excellent. Speaking of that, I know that we had some publicity over I think it was it the lunar eclipse, or was it the fireball?
The fireball.
George White was on KKTV, if I'm not mistaken. I think Dave Warner might also have been interviewed by the Gazette. I can't really remember for sure, but we've got some pretty good publicity over the last month or so. So that's pretty cool. Yes, Bruce.
The last large star party we did at Florissant Fossil Beds, the seeing conditions were the best I've ever seen. Normally it's a 1 to 5 scale. I would have called those 10s. It was so many objects that I would have said are outside your visible spectrum. Globular clusters were naked eye to me. Then again, I've got exceptional vision. But Andromeda was screaming. I had students who were just astounded at how much you can see out there at Florissant. Dark, crisp, beautiful. One bad caveat, cold. When we left, it was 14 degrees. That's Fahrenheit. Zodiacal light too. That was the part that was just astounding. Was I was walking up and I'm like, that's zodiacal light. That was astounding.
Sure, what sunset?
Yeah,
That's what we got.
that was over there. Zodiac light was over there.
All right. Anything else? Yes.
Just another comment on that fireball. While I didn't see it, I was following reports on it. Apparently, it went closest over Montrose, Colorado. And I saw one video of it that it rivaled Chelyabinsk in terms of its brightness from a dash cam video. I'm sure it was not as big, but it really, when it exploded, it was very bright. It probably sent some meteorites.
I didn't see anything reported on meteorite impacts. I kept looking.
It's such a remote area. I looked
Yeah.
on Google Earth. It's extremely remote.
An old club member, it used to be the president when I was vice president, was Chris Peterson. Has anybody talked with him lately?
I looked at his website, there was nothing on
Because
there.
he ran an all-sky network, a bunch of cameras that could literally triangulate where these things are supposedly coming down at. I was just wondering if anybody had reached out, talked to him. So. Okay, anybody else? Yeah, Tom.
Yeah, I just wanted also to add to the story on the lunar eclipse. It was It was, I've seen quite a few over the years. That was the second darkest one. I thought it was very dark. It was really beautiful to look at it. I was observing it in my nice refracting telescope. It was just a spectacular eclipse to watch, I thought.
Cool.
The only one darker than that was the one in, I think it was 91, the year that Mount Pinatubo in the Philippines went off and injected all that dust into the atmosphere. That I saw a lunar eclipse on the East Coast. I was back there on a trip, and it got so dark I couldn't find the moon. But this was the second darkest compared to that one.
Cool. All right, well, one thing I wanted to do here before we go is I could probably do this during the astrophotography section, but I thought I'd do it now. For those of you that know me, I do a lot of astrophotography. I do a lot of science. I've started to do a lot of science-related stuff. I also do a lot of pretty or aesthetic photos. And one thing that I did with Brian last November, October, is I did a presentation at his astrophotography group. But one thing it actually spurred me to do this. I have never had any really many images at all of open clusters. And what I decided to do was I decided to go back and, when you think of an open cluster, I mean, you're like, photograph, it's a bunch of stars. It's not going to be like the Andromeda Galaxy or the Great Nebula in Orion. But what's interesting is that I've kind of changed my mind on that. And I want to show you some of these photos that I took. These photos were taken with actually a fairly cheap William Optics refractor, $500 refractor. This is, Bruce, I need your help with this, saying that word.
I can't. Let me get my glasses.
And you said you had good eyes.
Yeah.
Como Maurice's? No, Melouette.
Melouette?
Melouette. Well, there's 5 different pronunciations of it. Melouette is sometimes.
All right, Melouette 111. This is in Coma Bernices. All of these cluster photos that I'm going to show you, they're only an hour and a half worth of exposure time. So there's not a lot of effort involved. You're not doing it for months upon months. This is just one photo taken. So go ahead and move to the next one. Anybody know what this is? Don't look at this name. M44, the Beehive cluster. Right? So that's the Beehive. I also did one of M41, which would be the next one.
Really see the difference in colors.
Yeah, one thing I did is I really hopped the saturation level up on these so that you can see the differences. Anybody else notice anything weird about these refractor photographs?
Yeah, you have diffraction
spikes. They have diffraction spikes. There's 2 ways to add diffraction spikes. Number one is you Photoshop them in. There are tools out there that called like Star Spikes Pro that allow you to do that. That is what I used in this instance. In other instances, I've used kite string, where you take kite string on the end of your telescope to give you a diffraction pattern. So that it's great because then you know that you're always in focus. The diffraction spikes are, not straight or whatever.
Are the tiny stars part of the cluster too?
A lot of them are, yeah, in the general area here, yes. Go ahead and move on to the next one. This is M37. This is more of a condensed area here.
Hold on one second. People keep getting fooled it's a globby, but it's not.
Yeah, right. This is in Ariga. Is that how you say it? Ariga. Right. Next one is M35. This is kind of cool. This is a Gemini here. You got the M35 here, and then you got a companion cluster here, which is NGC 2158. And then you also got a couple little clusters over here as well.
A lot of clusters.
A lot of clusters on this. Just to give you an idea, the field of view of these photographs is almost 3 degrees by 2 degrees, just to kind of give you an idea of that. And then the last cluster that I want to show is M46 and M47. Over here, this is kind of cool. We got M47 right here, and then we got M46 over here. And what's really cool is there's a little planetary nebula right there.
Too bad I can't see if she's turning away.
It's a little, it's a little difficult to see. And then the last photograph that I've been working on for the last couple months, you can go ahead and move to the next one, Stephen, is the California Nebula. I took this photograph. This is about 5.5 hours worth of exposure time, a hydrogen alpha blend with the color channels. So that's that. That's all I have. Yes, we're going to socialize for a good 15, 20 minutes, and we'll come back.
And sign the thing in the back.
And if any member needs an ID card, class
All right, Vince. All right, well, this part of the meeting is actually quite fun because we get to learn what's up in the night sky. So I'm going to introduce Vince Villa. As I said, he is very excited about
galaxies. Yeah, this time of year. Thanks, Matt.
Galaxies.
You want to drop a light for it? Yeah, that'd be great. Thanks. So, what's up? And I've also put some of the January information in here as well, since we didn't meet then, and my amateur shots of the lunar eclipse. So, next slide. Yeah. So we always start out with the lunar information. So the January full supermoon, as they were calling it, was the Wolf Moon. Down here at the bottom, I've greatly exaggerated kind of an orbit of something around their parent body. And you can see what makes it super is if something can move a lot closer in on this side as opposed to the the apoapsis side, then it appears a lot bigger. And that's why they were calling it super. There's nothing special about it. The February full moon here is the snow moon. We just had that. And then the March new moon, which I'd say we should have names for as astronomers, should be the Messier new moon, because the Messier marathon is traditionally this month. And then the March full moon, it will be the worm moon, and that will be on 20th of March. So next up. So lunar eclipse. Going in and coming out of the eclipse, and that was just a DSLR and a tripod telephoto lens, and tried to adjust the exposure lengths to get kind of balanced. It was more interested when it started than when it ended, so you can kind of see things. Next slide. So I like to start out these what's up with just looking east, right after sunset. So the new stuff that is finally reappearing. What kind of constellations are we looking at today? And then around the new moon, which being fairly close to here, there's not a huge difference there. So then I look up at zenith at midnight during the new moon to show you the kind of things that would be really good for viewing. Next slide. So as you can see, Ursa Major is in a nice position already, kind of climbing very high towards the north. Of course, that thing never totally goes away. It's one of these circumpolar constellations, but more important and near and dear to my heart, you can see Leo the Lion starting to rise and heralding the return of a ton of galaxies that are cool to look at. And Gemini and a lot of your winter constellations, still very nice placement at sunset at least. Next slide. So a couple of weeks later, new moon, things a little bit higher, but not a lot of change. Next slide. So now I tried doing this inverting thing because I was told that it was hard to see the normal contrast where the stars are white and most everything else is washed out. So looking straight up on the new moon, you've got this great view of the Dipper and Gemini twins, and then Leo about as high as it's going to get climbing in the sky as well. And then, your traditional springtime constellations. So I thought it would be kind of cool to talk about the galaxies, but to talk about a progression of getting further and further away from the solar system. So it was actually a nice tie-in that we had this cool solar system presentation, which, by the way, jumping up and down, seeing the moons, I can totally relate how cool that would be. I had a professor at university who related that when he was a kid, he got a telescope as a gift. He ended up making his own and going into astronomy. And I think the reason why, because he said he discovered Saturn. You know how you get a scope and you just immediately start pointing it to everything. And I've always been envious of that story, Next slide. Yeah. Cool. So Tom has got that. The first thing that we can look at actually over here actually looks pretty boring through most amateur telescopes. In fact, it's just this smattering of stars. It's actually a globular cluster, but doesn't look like a traditional globular cluster when you look at it. It's just a hazy patch. That's because it's super far away. They call it the Intergalactic Wanderer, or NGC 2419, and you can see it over here, the crosshairs. A little bit over towards Gemini and away from Leo there. And the distance of this thing is what makes it peculiar. It's sitting here at 91 kiloparsecs away, a huge distance away. And as a matter of fact, one of the dwarf galaxy companions of the Milky Way, the Large Magellanic Cloud, is only 50 kiloparsecs away. This thing, there's some debate that maybe it was stripped off from another galaxy. Most people think that's not true anymore. It's always been a part of the Milky Way, but it's just extremely far away and an extreme outlier. And in fact, such an outlier that it's further away from our companion galaxies. So that's kind of cool, but we're going to go further. Next slide. So we can go a little bit further just by looking up. You saw that the Big Dipper was in a nice position. We have one of our showpiece galaxies, Bode's Nebula. Called a nebula because it was discovered before they knew what galaxies were, M81. Beautiful spiral, you can see that. Now we're climbing up to about 3.6 megaparsecs away. We are definitely outside of the Milky Way, but that's very close by as far as galactic companions are concerned. I believe that's part of the local group, actually. Bruce is saying now.
16 million light years, that's outside.
Okay, so it's definitely closer than the Virgo Coma cluster, which we get into next, and that's one of the closest by ones, so I'm not sure where he placed. There's actually a cluster of a whole bunch of these galaxies. Of course, M82 is over near M81 as well. Those are all in the same group. I think some of those should blue shift. Next slide. So, of course, taking the best contribution to these astrophotos that we've ever had, the Hubble Space Telescope, and just ripping it off to make presentations look good. Here is M81. And this is just one of those beautiful spirals. So what you see here is the central core, these spheroid stars. They're the older stars that started forming first. They're metal poor. And then you see this spiral disk and all of this stuff they call modeling in here and dust lanes and stuff. This is where new stars are being born, and you can see a whole lot of neat things about this. You can literally see individual globular clusters when you have something like Hubble Space Telescope. That said, from a place like Gardner and an average size telescope, let's say a 6-inch scope or something, this thing will still show a nice spiral structure. And it's beautiful. Yeah, it's a very nice. Next. So let's continue this then. In fact, Steve mentioned the Leo triplet, and just by coincidence, I actually had that. This is one of the showpiece sets of galaxies. You can actually get 3 of these in a modest-sized scope in the same field of view, depending on what your configuration is, and see these gorgeous spirals. And these things now are at about 12 megaparsecs, which is interesting. It means they are in the Virgo Coma cluster, but they are actually closer than most of the members on that. They are in the near side of this cluster. This is fairly close as far as galaxies are concerned. Next slide. Gorgeous pictures again from different astronomical, the ESA this time. So you've got this edge-on spiral where you can see it turn towards us and all this gorgeous modeling going on over here, and then you can see your classic spirals as well. And if you look at this through a telescope out in Gardner, you will see something similar to this. This one is quite a bit harder to see than the other two, but it's still a very nice showpiece. A lot of people say, oh, don't look at galaxies. They're faint fuzzies and they're not worth your time. Well, the backstory is interesting and makes it worth a look anyways, but these ones I think actually do show a lot of this structure, and you can really start to see some of this detail. Next slide. So let's go back over here into Ursa Major. And I've highlighted a star just because there's nothing over in this region. That was the closest thing that I could get to. This patch of the sky is kind of close to Bode's Nebula, but it's relatively empty. We're within a few arc seconds of where this is. We get, next slide, the Hubble Deep Field. So not the ultra deep field where they've seen a whole bunch of cool gravitational lensing, but this was kind of the first one. The principal investigator of Hubble had a little bit of time allocated just for whatever kind of crazy science experiment he wanted to run. Okay, so the astronomers got their time on Hubble, and it was very contested, as you might imagine. And he was given a little bit of time as a tax for being the principal investigator and got to do something. He took a gamble and just aimed it at that empty patch of the sky where there hadn't been anything, and did a ton of large exposures. And this is what he gets. Every one of those things that looks like a star, except for the ones with the diffraction spike, which really are stars in a way, are galaxies. And the whole point is this, and some of those galaxies are going out to the edge of the observable universe. We're talking, 13 point something billion light years away. The cool thing about this is that it tells you what time of the year we're at, okay? In the springtime, we are looking kind of out of that flat disk pancake that the Milky Way is a spiral. We're kind of out in one of these outer arms, and usually we like to look towards the core. There's all these neat nebulas. Sagittarius is over there, and we can see all these cool things, and that's definitely fun in the summertime. But in the springtime, we're positioned in such a way that at nighttime we can look out away from the core. And it's one of the only times of the year that we can do that. And we're looking out to the vastness of empty open space without a lot of dust from the Milky Way to obscure the view. So that's why I was so excited with this. And that's why I was, Matt was saying I'm giddy. Is that?
Jumping up and down.
Oh, you know it. So, in fact, if you go, so right now is a great time also to go look at the Virgo coma cluster. So back in Leo, you start heading over towards Boots or Booties. Boots. So you can make kind of a nice little asterism from two of the brightest stars, Spica and I think it's Regulus, and make a little kite design. You put your scope there, and you can literally get 12, 13 of these spirals in one of our telescopes. I've done it. I mean, how cool is that? You're going through the field and just ignoring half of them because it's like, well, that's pretty, but not as pretty. And you just dismiss 200 billion solar systems, in a blink of an eye to go to something cooler. So only in this hobby. Next. So switching gears and coming back a little closer. Comets. I didn't mention that 41P Wharton comet when it got nice and bright. So now I'm keeping a closer eye on those. Right now, your best bet is this C2018, so it was fairly recently discovered, actually discovered by an astronomer and not one of these synoptic survey telescopes. Y1 Iwamoto is currently the brightest comet. It just passed its closest approach, and so it's actually dimming now, but it's 8th magnitude, and it's over here in Auriga near Capella. So for the planets, I think I left these a little bit. Yeah,
just a quick comment about that. I was watching it with binoculars when it made its closest approach, and in 2 nights it crossed Leo. 2 nights.
It's moving, huh?
That's it.
So that's the kind of thing.
It's going, I think, 66 kilometers a second.
Is it? And it's probably still fairly close to that. So that's the kind of thing that if you set up early and take a note of it, and then come back at the end of the observatory, you will see proper motion in your observing session, which is pretty cool. Thanks, Doug. So as far as planets is concerned, Mars is kind of lowish to the east at sunset, but still probably our best bet as far as evening planets are concerned. Venus, of course, being a brilliant morning star. Jupiter is climbing through. It's actually a little bit higher. I think I didn't update that one from January. So you still have a reasonable shot at Jupiter. It's going to be kind of twilight dawnish. It's not the best view of Jupiter you'll get. Saturn and Mercury are pretty still largely lost in the sun's glare. Mercury is actually heading back to being an evening star, and you have a pretty good chance. I think its greatest separation of the year is going to be this month. Mercury is always a challenging target. In fact, what I like to do with that is you can go figure out, you can superimpose landscapes in Stellarium. You put Pikes Peak over there from your location and then figure out where Mercury should be at a certain time and then go exactly where to look, based on relative to the peak. And that's a pretty surefire way to find Mercury. So I think that was actually all I had. I kind of went a lot faster through there. So my parting shot, next slide. Oh, nope, I got one other thing, sorry. Messier and bright objects. If you like those globular clusters, this is not your month, unless you want to stay up late for them, because then we've got this Messier marathon. So there's a 2-week period in the end of March and early April that you can theoretically get all Messier objects in one night if you stay up all night, and if you're not too far north latitude, which we should be able to do from here. It's going to be a challenge this year because we've got moonlight during those 2 weekends. Your best bet, if you want, is going to be March 9th to 10th if you're stuck to weekends near new moon, or March 30th and 31st, and you'll probably lose one or the other in glare, early evening or early morning Messier object. But otherwise, you still have nice images of Matt showed M44. Pleiades is still nicely placed. There's 2 clusters over in Puppis that Matt actually showed as well are very nice. And then the double cluster is still very well placed over near Cassiopeia. And then all of the nebulas are actually pretty well over in Ursa Major, and Eskimo Nebula is over there as well. Very nice planetary you can take a look at. So with that, my parting shot. There we go. The telescope you might be interested in, actually, this was the Iowa 24-inch PNC, and a younger Rachel.
Awesome.
Thanks, guys.
Thank you very much. Okay, well, we get to go into committee reports now. Brian, would you like to start? Okay, tell everybody what you do.
All right. We have our two imaging groups that you're interested in doing some astrophotography or behind the equipment. We have a kind of a regular group that meets 1 week from tonight at my home, and then 2 days later on Thursday, we have a novice group. We've only met twice, but there's a lot of excitement and passion in that group. It's kind of amazing. So that is something that if you're interested, please give me before you leave your name and your contact information, and I'll put you on a list or I'll email the events that are happening. There's this coming Tuesday, this next Tuesday at my home at the regular meeting, we're going to do a section which actually was prompted by something Robert did probably about, I don't know, 6 months ago on imaging nightscapes. Because there are also so many beginners, probably about 15 or so that are just starting to get into it, well, that would probably be a good time to visit it again, but in a little bit different way, where we're actually be able to discuss and show some of the different techniques that you can use to capture them, as well as some of the equipment that you could use based on what you have. What are your options, and then also some processing tips. And that will be this, again, next Tuesday at my home at 6:30 to 8. The following Tuesday, Thursday, excuse me, the beginners group is, it's a little bit similar, but this will be the first night now, because it's our third meeting, where we're going to spend half the night actually going out and helping kind of one-on-one those novices to actually bring their equipment and learn how to use it, whether it's the camera or the mount or your scope or your whole setup, or how to find things. So it's kind of a one-on-one, hands-on approach. With that, we'll also be discussing ahead of time imaging some star trails, as well as camera settings and things like that. That will be really helpful. So if you're interested, you want to come, it's free. It's not like Texas where they charge you $50 an hour to go to a meeting. So you can have a lot of fun doing that. One other thing I want to bring up, and that is a number of you are interested in volunteering at the Space Foundation Space Symposium. I have been involved with it for, I don't know, 4 or 5 years. And there's a process where you can go through and become a volunteer. However, it's such a high security thing that it's not necessarily easy to get into it. For those of you who don't know what the Space Symposium is, it's like the most amazing gathering of space, both military and civilian, about half and half, gathering in the world. Last year we had about 14,000 people come from 40 different countries, and they have an exhibit hall where if you volunteer, you're actually allowed to go in and spend some time in the exhibit halls. I had more fun discussing the rocket designs with the CEO of Rocketdyne. Like, what do I know about rockets, you know? But I mean, you can go and talk with people. They don't want you to bug them if you don't know anything. But it's a real fun thing to do. The volunteering part. here's what I can say. If you're interested, again, give me your email and I will send you a little email that will have a link that you could sign up with. And one of the things that are required normally are somebody to recommend you. Well, assuming you're not a terrorist or something bad, let me know, and then you can use my name to sign up in there and volunteer. Now, the dates are April 18th, is that right? April 8th to the 11th. It's that second week in April. But you only have to volunteer one night. I'm working on Mondays and Tuesdays. They're like 6, 12-hour shifts. I kind of head up a security detail. You don't have to work with me. There are all kinds of jobs that you could do. If you want to volunteer or work as part of one of my security groups, the second shift on Mondays or Tuesdays is the one that I'm involved with. But you can do whatever you like. The thing is, I need your name, and then I can forward an email that will tell you how to get in an easy way. And if you want to look more about it, I'll have this here. You can look at afterwards for a minute too.
Brian, what is this? Where?
It's held at the Broadmoor.
Oh, okay.
Like the Broadmoor has expanded greatly because of it, and they're also building a whole new extension, which is, they used to have tents there. It's not ready this year, but it's, you know, the number of people showing up, it's amazing, from all countries all over the world, and these are like the heads of state. Some of them are vice presidents, generals. Last year I had to kick out the head of NATO for the Italian government because he was in the wrong place. I mean, it's kind of fun, but it's a
Brian,
it's a great experience.
I don't mean to cut you off, but we have to move on because we are cutting short on time.
Do you have any other questions?
Just talk to me afterwards. Bruce, you want to talk a little bit about long-term planning?
Long-term planning committee, we are looking at giving a home to that beautiful telescope we've received from the Air Force Academy. We're making great progress. We now have developed a fact sheet, so when we go out and encounter people, particularly people who have possible land or location or some kind of connections that work with us. Our committee is meeting once a month. We've developed now a contact list. We're going to start reaching out to them officially, seeing what they can support with us. This is not only physically a location, but in some cases, this is going to be local people who are willing to help sponsor us or provide sponsorship through some organization to help fund this. This is a beautiful telescope. Want more details? Show up to one of the committee meetings. They'll be up there posted on the calendar.
All right. Perfect. Yes.
Real quick. So Dave Warner's online, and he wanted to add something to the Space Symposium comments. So the Star Party at the Space Symposium is separate. That's on April 10th, and he'll be requesting by name volunteers in the near future. So, keep that in mind if you can help out. He's looking for volunteers.
Perfect. Next up, if we don't mind, I would like to do the treasurer's report. Are you okay with that? Okay.
So, as Matt mentioned earlier, I'm the interim treasurer and lifetime. What's that? Lifetime. So, I took this over when Jill Furman was elected for a second term in 2019, but her and Jason are living in Wisconsin now. She took her new job, so I stepped in.
They bailed on us.
So I stepped in, and so our treasurer's reports are given quarterly. So at this meeting, I will give you a very brief report for the fourth quarter of 2018, the last 3 months, and that was Jill's watch. And all I'll tell you about that is that during the fourth quarter of 2018, we had no activity on the RMSS Starry Meadows account, but we did have a net gain of $904 to our CS Astro account. I'll give you, so that's where we stand for the fourth quarter of 2018. I'll be giving a report in April, the April meeting for the first quarter. However, now just give you a quick preview. Couple things that have happened. One is we completed migration to the HostGator, working with Stephen on that primarily, migrated to our HostGator cloud service. That saved us about $450 a month on our previous shared service. I've separated out the budgets for CSAS and RMSS, and we also have separate savings accounts at AMP for CS Astro and RMSS Starry Meadows, so kind of maintaining a separation of those. The most recent activity was a check in the amount of $1,378 paid to Huerfano County for the property taxes. Okay, and I did do a reconciliation on the accounts for the end of January using the statements from PayPal and everything reconciled and balanced. So I'm hoping to have the same success end of February. That's my report.
Great, thank you. Perfect. Just one thing that was not mentioned is that account balances, we are still allocating money for the Starry Meadows electrical build out. That will be coming out of our checkbook sometime within the next couple of months.
Right. That's already in our budget.
Right. Which is in our budget. And with that, I'd like to bring Barry Young up here, our Starry Meadows chairman.
Put my first photo up there, that'd be great. Can I use that order? Great, which one? The red. The red, okay. Just want to talk quickly about where we've come. And I want to say kudos to Jason because he got us a lot of good things for not a lot of money. So if you're still in contact with Jason, mention this to him because he really worked hard. Power feeds in from the Delora Ranch. Whoops, we'll go back. The power feeds in from the Delora Ranch up here, comes down these power poles right here. This power pole is across the road, but it actually is on our property. Feeds across here. Now on that pole right there is a transformer. And at that point, normally they would just hang a meter there and then we would be responsible from here all the way up to here, which would be about 200 feet. That's a lot of trenching, a lot of pretty good sized wire. So, but basically they gave us this for free and they put in a meter pedestal. So all we were responsible for is about 100 feet to there. Now, here's a picture of, this is the meter pedestal and you're looking back, this back over here, that's the power pole that has the transformer on it. So they gave us all this for free. And then the cool part about this is we don't have any wires overhead, in this area. And we're standing right on the road that's right next to the town hall. So it gives you a little bit of perspective. When you go down and you look at, here's the power pole, you look down, clear in the back here, you can see the road. There's kind of a whoop-de-doo in the road here, and there's a power pole there. So these wires are the only thing that's going over our property, which is a really cool deal, I think. I'll let you go ahead and you shut that off. I'll tell you a little bit. The committee's been great to work with, and one thing that's exciting to me is that they get a lot of things done very efficiently. And also, there's been a real interest in looking out for everyone that's a club member, whether you're camping down there in a car, whether you've got an RV, whether you're sleeping in a tent, whatever you're doing. And I really appreciate that because we're really looking at the club as a whole. But what we've done since I started the beginning of January, we've had 2 meetings, got a lot done. There's a drawing over here, electrical drawing, if you'd like to peruse it. I really don't have time to answer questions just due to our time restraints, but I'm always open for emails. If you want to come ask me any question, I'm glad to help with that. I would ask if you're interested, get on our list and you can see it. We do a lot of things online. Basically, we put information out, everybody looks it over, we come in, we have our meetings, and it's very efficient because everybody knows what we're talking about and we can make a decision. I'm just going to go over some quick things that we're looking for or some quick bullet points for Starry Meadows. We looked at white lighting, which is basically only for maintenance and emergencies. Red indirect lighting, enough red to where we could light up after one of our presentations without blinding everybody. Exterior fixtures, which are required by code with full cutoff, but with red bulbs for the entrances, at least at the door entrances. Gable fans to help cool it down so we don't have the overheating issues we had last year. Get about 10 air exchangers per hour. I mean, a lot of flow. Also power for our vendors, both 220 and 110. Some south side vendor power in case the Boy Scouts need it at some point. Device charging area for laptops and cell phones and those kind of things. Power packs, various things. 12-volt lead acid charging area. Extension reels in the middle of the room so we can drop down and provide temporary tables with power for laptops. Exterior safety cutoff switch so that we can get the power shut off in an emergency. A lockable 200 amp power will give us a panel, which will give us a lot of power, enough to feed any other future projects that we might choose out on the land. So we're already looking at the observatory and the future possible observing pads. Next month, I'm going to bring back information on the use policy. This design will support any use policy that we've discussed so far, and probably then some. So that was the main thing. We had to come up with a base. We're going to finalize to get it to the board next month, and I'll bring that to you after it's finalized. We did have a work day at Starry Meadows, and we had to remove the generator wiring, just temporary stuff, and we had some red lighting that didn't meet code. We had to take that out. A few minor building repairs, we did that. I'd like to thank the folks here that helped us out, and that's Tom Mullican, Tom Zimmerman, Doug Cook, Eric Kaler, Ted Hupper, JD Andrade, who is back here. He's a new member. He also donated a microwave for us down there so folks can heat up things when we're down there, and also a large floor fan, big and industrial thing. So thank you so much, JD. Appreciate that. Construction should start in, I'm thinking early April. It's pretty wet down there, and they've been getting a lot of snow. It's pretty cold. So we'll update you next month on that.
Great, thank you. Awesome. Oh, you think you're not? Go ahead, sit up at the top. Go for it.
Okay, so we have quite a number of new folks here, so let me just refresh or explain what is Rocky Mountain Star Stare. It's RMSS. That's an annual big star party we put on. It's a national-wide event. We get people from all kinds of countries, or all over the United States, and people from Canada too, usually. This year, it's from the 26th to the 30th. It's on our private property, Starry Meadows, and we're coming along very nice. This year's theme is Sagittarius, the Milky Way. That's the diet or the picture that we're putting on our merchandise that we sell. We've got a schedule pretty much all laid in. We have our speakers. I'm still waiting on vendors. I've reached out for like the third time. We do have a new vendor that's coming this year. It's Mile High Astronomy. Out of Denver. I reached out to those guys. They will be there, and they'll be bringing telescopes and things to show off what they've got there. We also have, just so you know, they're confirmed. The other confirms are Ajima Optics. That's the Trigubova family from Ukraine. They're making nice refracting telescopes, and they're also a presenter. They're doing a presentation on Friday night on the life of Dr. Matsuton. They come from the Ukraine. They were able to interview family and friends of Dr. Matsuton, and they're going to be talking about Dr. Matsuton and his inventions optically. So that's all interesting. Everything's coming along very nicely at this point. We went online about 2 weeks ago. I just checked a few minutes ago. We've got 45 registrations so far for the adults, 1 teen and 4 children under the age of 13 at this point. So, you know, we're kind of right where we need to be at this point. Yeah, it is still February, so we're doing just fine. Anybody have any questions on RMSS at this point? Our next meeting, I should have that. It's on the.
We can talk about the schedule, Tom.
On the schedule when we get there. Okay, let's put that out. It's on a Saturday. I would say it's in 2 weeks.
Yeah.
On a Saturday at the coffee shop. And we do have when you register, we do have a block for volunteering. make sure you check that off. If you're inclined to volunteer. Next month, I'll start filling in the chart of all the different volunteer positions we need filled. So please be generous with your time.
Thank you very much, Tom. Last but not least, outreach. Hi, Dave.
Bruce, we're gonna cover for Dave since he's not here, but in case you're wondering, for those new people, we've got the 5th largest outreach program in the country for astronomy. That's not bad. 2,700 people showed up at Garden of the Gods. That's not bad. I have a feeling we're going to break our record this year. We've had some great success already previously this month, but the key is to look at where are we going from here. Move to March if you could. Blank, no. As you can see, tomorrow night, Space Foundation. Thursday night, Rocky Mountain Classical Academy. Again, Classical Academy the week after that, Horizon Middle School. Florissant, we need bodies and people there for Florissant. It is gorgeous, it's beautiful. Please, this one is worth your time. Even if you don't have a telescope, you're new to it, show up, you'll be astounded. There's Free Scout Day at the Dinosaur Resource Center. That is so much fun. Doug has shown up in the past, several of us show off our meteorites, do solar observing. Just because it's in daytime doesn't mean we're not doing great stuff. There's an equinox. Oh man, I'm signed up for another equinox site. Okay, I keep forgetting about those as we go through. And then of course we start moving into more Space Foundation and then moving into the next month. But we're gonna have another meeting before then, so you'll get a refresh on the calendar. Keep an eye out here on the side on what happens on Saturdays. Our MSS meeting right here. It's important so we can build that. You'll also see the committee for the future planning. We got another York High School there as we're going along. One other aspect of our outreach program is, I want a touch screen. That'd be fun up here. If you don't know about it, looking up on KRCC. Every Monday at 9 a.m. and 9 p.m. is a small segment on astronomy done by 2 of our astronomers here. Hal Bidlack is dominantly takes those once a month. He allows me one small segment that we get pulled in there. They've got a full bit. You can pull these down as podcasts if you don't hear them live. But this is a great outreach in this community. KRCC, the local NPR station, loves us. So more outreach. Let us know if we can help you become an outreach person.
Perfect. Steve, can you go back to the calendar real quick? Several things. Just a reminder about, I think it's tomorrow, the Space Foundation here. We need volunteers for that because that will count for one of our 6 events. And then also the event right here on the 28th. There's supposed to be 500 people or so showing up at that. So, well, still, if we could get some volunteers out there for that and represent ourselves well, that would be greatly appreciated. So other than that, I don't have anything else other than there is an after meeting, which is basically go over to Village Inn. It's a social time. Village Inn, if anybody wants to go. And for those of you who aren't aware, there is also a pre-meeting social, which is at Trinity Brewing. So there's options there as well. And just remember, next month we have this room at 6 o'clock. We'll be starting at 6:30. However, if you still want to come early and chat with folks or whatever, you're more than willing to do that. So other than that, does anybody else have anything? If we're good. If you folks at the back, or if they can help me, because we have to put this room back into classroom configuration. If you could bring the black folding chairs over to this door, it would be greatly appreciated. So other than that, meeting's adjourned.